Good morning, my dear students. Myself Dhiraj Mandal. I welcome to all of you to this session of thermodynamics. Today I am going to discuss about the heat and work, a new chapter, chapter number 2, heat and work. So, first chapter, basic concept of thermodynamics, it is already uploaded. You can see the 6th lecture. Okay, next lecture is your heat and work, on your heat and work. So let's start. So first of all, what is heat? Heat is defined as a form of energy transferred across the boundaries of a system because of temperature difference between a system and its surrounding and in the direction of higher temperature to a lower temperature reservoir. So basically heat is like a form of energy. And now what is energy? I am coming afterward. You just consider this one is your two temperature reservoir, this one reservoir 1, temperature reservoir 1 T1 and temperature reservoir 2. Now heat is a form of energy which is always flowing from higher temperature reservoir to lower temperature reservoir, and when there is some heat interaction, and with the help of that heat interaction we can get some work. Okay, so heat is one kind of energy, okay, which is just flowing from higher to lower temperature, and this is the temperature gradient. Okay, now what is energy? Energy, that means a what kind energy is your work per unit second, capacity of work doing per unit second. So that is your watt, unit is your watt, joule per second. Okay, so what is the work you are doing per unit time? That is your energy. Now energy, it can exist in the form of mechanical energy, electrical energy, chemical energy, kinetic, potential, electrical, magnetic, all the form of energy are there. So in the thermodynamics, all kind of, that means this total energy is discussed, and basically in the form of heat and work, how heat is converting into work and how work is converting into heat, that is discussed here. That means the heat to work and work to heat. Okay, so these will be discussed, that means this is discussed in thermodynamics, heat and work interaction. And all of you know that there are energy is the heat is energy in transit. That means there are two type of energy: energy in storage and energy in transit. So energy in storage means your internal energy, and energy in transit means your heat and work. Okay, so which can be transferred. Okay, so this is heat. Now there are three types of heat transfer process, you know. So you know that in your madhyamik level already you have gone through how many types of heat transfer. Three types of heat transfer are there. Number one is your conduction, number one is your convection your, and number two is three is your radiation. So this is your, the by the help of these three process, heat can be transferred from a system to surrounding. So what is conduction? The process by which heat or electricity is directly transmitted through the material of a substance when there is a difference of temperature or of electrical potential difference, okay, between adjoining region without movement of the material. So conduction is the process where you just understand, let us consider this is a material. Now the material is consisting of infinite number of molecules. Now these molecules are vibrating, and the heat energy or the electrical energy, whatever the energy, it is transmitting, but the movement of the molecules is not there. So without the movement of the molecule, the heat or electricity is transmitted, and by the help of this process, the process is called your conduction process, and by the help of this process the heat or your electricity, whatever the energy, is transmitting. Okay, so basically conduction process is that type of process where it is possible in the solid medium. Okay, so in the solid, the molecule to molecule heat is transmitting when the molecule is vibrating, but it is not changing its position. Okay, just it is vibrating. So this is your conduction process, and this is how heat transfer can be possible. So what is the example of this conduction process? Just let us consider a rod, a steel rod. You are that means you are putting this in the uh, this is, let us consider, this is your fire. Okay, now this putting this you are putting this in on a fire. So what happened, heat will be transferred from this position to this position, and this is your hand. So you will see that after 5 minutes you will feel, after some time you will feel some, this region will be hot, but at first initially this region will be, temperature will be increased, then after that heat will be transferred. Okay, so this is your conduction. Next is your convection. So convection, what is convection process? The convection is the heat transfer due to bulk movement of molecules within fluids such as gases and liquid, including molten rock. Okay, so convection process means the, if let us consider this is your let us consider this is your pipe. Okay, now what water is flowing through this pipe, and this is another pipe where cold water is flowing. Okay, now what happened, because of this hot temperature, this hot temperature, that means by the help of convection process, that means when the hot water is there, then hot water, the temperature will be transferred from system to this surrounding here. So air will be temperature of the air will be increased, and that air is just transferring the heat to the cold water. Okay, so what happened, the mass movement, or the movement of the molecules is there. Okay, so you can see, that means the water is flowing, say, and it is having some temperature, so the heat can be transferred. So you can, that means in case of conduction process, there is not any kind of change of position of molecules, but in case of convection process, the molecule is changing its position and the heat is transferred by the help of the mass movement of the molecules. Okay, so this is your what is the example of this, in your boiler you can see, the by the help of convection process heat is transferred. That means from the water to air to water. Okay, so this is how heat can be transferred. Or a hot cup of tea you are placing, so by the help of convection process heat is coming in the atmosphere. Okay, so medium can be changed here. Okay, from one medium to another medium the heat is transferred. Okay, so this is your convection process. Now next is your very important, that is your radiation process. So what is radiation process? uh, Radiation process means, let us consider the radiation process. The definition of radiation is, the radiation is the emission or transmission of energy in the form of wave or particles through space or through a material medium. That means from sun to earth. Okay, so whatever the heat is coming in the, if it is your sun, this is your earth, so heat is coming from sun to earth by the help of radiation process. So it does not require any kind of medium. Okay, so without any medium the heat can be transferred by with in the form of wave or particle. Okay, so that is your, because of the radiation. In the boiler or furnace, the whole kind of heat transfer can be possible, that is your conduction, convection and radiation. Okay, now conduction process by the help of Fourier's law, that is your Q is equal to minus Ka dt by dx. This is the equation dt by dx. By the help of this equation, you can calculate how much heat is transferred from system to surrounding. That means if it is your system wall and this is your temperature T1 and this is your T2 and this difference is your x dx, sorry, this is your dx. Okay, so if you know the thermal conductivity of this material, and remember this one is your, it may be your, it is a solid material. Okay, so thermal conductivity, if you know the area, if you know the temperature difference, this system and surrounding temperature difference, and this is the distance, so you can find out the heat, how much heat is transferred from system to surrounding by the help of conduction process. Next is convection process. So convection process, the heat transfer, it is the formula is your Q is equal to H into or HA T water minus T fluid, whatever. That means when heat is flowing from one medium to another medium, from water to air or air to water, whatever, so that temperature difference delta T, so and the delta T into area into the, this H is called your heat transfer coefficient, that is your convective heat transfer coefficient H. Okay, so this is your, by the help of Newton's law of cooling, you can find out the how much heat is transferred by the help of the convection process. So this is the formula. Okay, next is your in the heat when radiation, by the help of radiation, if heat is transferred, so it is the formula sigma A del T to the power T1 to the power 4 minus T2 to the power. Here you can see this is your heat transfer, this one is your heat transfer heat, and this is your sigma Stephen Boltzmann's constant, this is your area, and this is your source temperature, this is sink temperature. So this is how you can find out by the help of radiation process how much heat is transferred from system to surrounding. So this is your chapter heat transfer sorry, heat transfer subject is there. So in the heat transfer subject, all these heat transfer process of heat transfer are discussed elaborately. So this is not in your syllabus right now. So today up to this, I think after this heat and work and the process of heat transfer mode is clear. So if you have any doubt, and then you can write me in the comment section. Okay, thank you for listening. Jai Hind.